Hello. In this video, we're going to talk about a simple idea, but it has significant impact concerning lists, and actually a collection of variables which are called reference types. So to help illustrate this, we're not going to talk about lists initially. We're going to take a look at a simple function call using an integer. So just to get an idea what's happening here, we create a variable called num, we print it, and then we invoke some function called doSomething. And what doSomething does is it takes the value of num and passes it into a, and then a gets changed to 99. So when I print num again afterwards, what happens is I get this. And this sometimes causes some confusion because people will say, well, wait a second, I've passed this into the function, I've changed it to 99. So we're going to draw a little picture here to make sure we understand what's happening. So when we reach line 6, what happens is a space in memory is created and it's called num, and the computer stores the value 1 inside of that. So then when we print it out, we get 1. Simple enough. But when we evoke the doSomething function, a new variable space is created called a, and that stores the value contained within num, which happens to be 1. So this is what's really important here. There are two distinct variables. They are completely separate now. If we change one, it has no impact on the other. So of course, as we continue through the function, this 1 gets modified to 99. And when the function completes, this variable disappears because it's no longer needed. It's defined within the function. And so when I print this out, num hasn't changed. And if you've been working with me, you've kind of seen this. And one of the things that we've kind of learned is this idea of we can do this. We can type in return a. And so what that does is when we reach this line, it takes whatever the returned is and spits it out. Now this doesn't change the value of num yet. And the reason why is simple. And let's actually just give this a run to show that. So notice I still get 1, 1. So why is that? So what happens again is I create this variable called num, I invoke doSomething, and I pass it into a, so sure enough, this is a, and this gets the value 1, and then I return a, but notice, that means this becomes whatever a is, but I haven't assigned it to anything. So what I need to do now is I need to put num equals, and now when I run this, we get 99. So again, we run our program, a becomes 99, that gets returned out of the function, so this disappears, and this becomes 99. And that change is reflected after the function is done. So let's apply this to lists and watch what happens. So I'm just going to kind of hit enter a couple times. I'm going to comment out this code. And I'm going to make some definition called change list. And it's going to take some parameter again. And it's going to say list at 0 equals 999. So that's essentially, I'm going to modify the first element in the list. So I'm going to create a temporary list called let's call it L. L equals, and we'll just put 1, 2, 3, 4, 5 in there. And then I'm going to print L. I'll invoke the function change list, just to kind of get on the same page. Change list L, and then I'm going to print the list again. So based on our previous discussion, we might imagine that what's going to happen here is I'm going to run this. I'm going to print out the list, so I'll get 1, 2, 3, 4, 5. I'll invoke the function change list, so I'll jump up here, run the function, and then I'm going to print the list again. And I might think it's not going to change, but notice there's an actual change in the list. So what's happening? Well, here's the thing. Because lists are actually really complicated variables in that when I create a list, I could put 1 element in it, or I could put 1 million elements in it. Creating a brand new copy is really inefficient. So what happens is a copy isn't passed in, but a reference to where it lives. So if we draw the same kind of memory diagram again, if If we look at line 9, we create this variable called L, and then it points to somewhere in memory where it stores that list. How it does that, I don't exactly know. 1, 2, 3, I should be able to count here, 4, 5. But the point is that the memory space stores a reference to where it lives. So when I invoke this function changeList, I'm going to make a new variable just like before. But what I pass into it is not the actual list, is I pass a reference to where it lives. It's kind of like if I'm pointing at a door, and then I tell you to point at the same door, and you then open the doors, both of us see the door change. There's only one actual door. So when this function goes and modifies the list, which is it takes the first element and changes it to 999, and then this function stops, it ends, and so this temporary variable for the function disappears, I actually have a changed list. This is actually a very, very important idea. And it has some significant impacts for some things we'll do later. So the big idea and the big takeaway we want to have from this, which are all my drawings, is that lists are reference variables. This means that when they are passed to functions, a copy of the list isn't created. A reference to where it to the location of the list is passed. Therefore, any changes, therefore, there is only one list, and any changes are permanent when the function ends. So that's all I want to kind of get across in this video, is this idea that if I have a function that takes an integer or a float or a string, what happens is when that information is passed into the function, an exact copy of that data is made. So any changes aren't reflected when it's done unless you return the value. But if I pass a list or any reference variable, when the function ends, the changes are permanent because we're not making a new copy of the list to give to the function to use. We're actually just passing a reference. And again, a nice way to think about it is imagine you and I are standing in a room and I'm pointing at a door, and then I tell you to point at the same door. If either one of us changes that door, we both see the change. We both reference the door, but there's only one door. Anyways, I hope this video helped. Take a second to think about this concept, because it is a little idea, but it has significant impacts in terms of your future programming. Have a great day.